Our final project is on music.
The development of music required an understanding of physics as musical instruments are influenced by physics laws. The progression of these instruments would not have been possible without the knowledge gained through the study of physics, as the understanding of physics is crucial for the development of musical instruments.
Every source of sound comes from vibrations, no matter what sound it is. If it is a musical instrument or something falling to the ground, sound waves are made when objects vibrate and cause the surrounding air molecules to vibrate too, starting a chain reaction of sound wave vibrations throughout the medium. Faster molecules create compression, while slower ones create refraction, causing sound waves to move. If you change the wavelength, then the frequency also changes. This then creates a new pitch. This is why we hear different sounds and not everything sounding the same. When a note has a low frequency, the wavelength is long, and if the note has a high pitch, the wavelength will be very short. This then means that the relationship between wavelength and frequency is as the frequency increases, the wavelength decreases. An example is when you press down the string of a guitar, the amount of vibration that string shortens, meaning the wavelength also decreases, causing the frequency to be higher. A tuning fork is a steel-based object that is used to make a fixed sound. A rubber hammer is hit against the steel bars, which makes the steel bars vibrate. The movement of the steel bars disturb the molecules surrounding the object. As the bars move outwards from its homeostatic position, the bars compress the surrounding molecules into a tiny space. This makes a high-pressure region. As the tuning fork bars move inward from its normal position, this allows the air surrounding the fork to expand, which then produces a low-pressure region. These high-pressure regions are called compressions, and the low-pressure regions are called refractions. This pattern happens multiple times in a few seconds. This is how we are able to hear the sound and pitch coming from the tuning fork.
Acoustic guitars use strings to transmit vibrations through the neck of the body, resonating throughout the instrument. The tension of the strings affect the frequency, with thicker or longer strings vibrating more rapidly, creating pressure waves with higher frequencies. These are the different frequencies for the tuning forks and the acoustic guitars. The same note sounds different on different instruments due to the unique harmonic overtones and envelope of each instrument. Harmonics, which are the integer multiples of the fundamental frequencies and strongest amplitude, create different frequencies when played, resulting in a distinct sound. The wavelength of a guitar is 1.58 meters, and its length is calculated by dividing the wavelength by the first harmonic. The sound produced by a guitar produces a longitude wave in the air. The tuning for open strings on the guitar are E2, A2, D3, G3, and E4. A tuning fork produces sound waves, which are longitude waves and with a wavelength of 0.711 meters.
This project allowed us to gain a deeper understanding on the connection between music and physics. Since we both had a genuine interest in this subject, it made the learning process enjoyable and engaging. We found it fascinating to see how physics is essential to fully comprehend certain musical concepts. Through this project, we learned about tuning forks, their frequencies, and how they function. We also discovered that different instruments produce the same notes in varying frequencies, which was particularly intriguing. Overall, we thoroughly enjoyed this project, as it not only deepened our appreciation for a topic we are passionate about, but also taught us new concepts. Specifically, we gained valuable insights into the workings of tuning forks and expanding our knowledge about guitars and how they can produce sound.